Now we are on section 5.2, ways to prove that quadrilaterals are parallelograms. So, in the previous section, we had a parallelogram and we found out and discovered properties of it. So we went from here to here. Now we're starting with a quadrilateral with certain properties and showing it's a parallelogram. This is the kind of stuff people need to know when they're doing some surveying, when you're building, when you're constructing something out of wood. We need to know, okay, this is four-sided, but are the sides parallel? Is this a parallelogram? And in the future, is this a rectangle or a parallelogram? Makes a difference. So, first thing. In the first theorem, we've got a quadrilateral with opposite sides congruent. So this and this pair are congruent. This and this is congruent. This pair is also congruent. So TS congruent to QR and TQ congruent to RS. And that's our given. Now we've got to try to prove parallelism. Remember, the way we've learned to show lines are parallel are by showing angles are congruent or same side interior. So we got to do something like that with these. Probably do congruence, but we got to find, like, to show lines parallel, if we have a transversal, remember, if alternate interior angles are congruent, then the lines are parallel. If same side interior are supplementary, the lines are parallel. If alternate exterior are congruent, the lines are parallel. If corresponding are congruent, the lines are parallel. So there are a number of things we can do. We just got to see what goes in this case. Because remember, to show something's a parallelogram, we have to show that it fits the definition. We got to start with this and work our way to showing that opposite sides are parallel. And that's why we were talking about the angles being congruent, so that we can show opposite sides parallel. Remember our definition at the beginning of section 5.1? That's what we got to try to get back to. Now, to show angles are congruent, which we want to do to show that the lines are parallel, we've probably got to use triangles. Notice there's not a triangle there, so we probably got to make one with an auxiliary line. Auxiliary meaning helping. We need a helping line. So we'll draw one in. Okay, QS. And we can do that because 2 points determine a line. And I'll go ahead and write that down. But notice we've got a triangle here, TSQ, and then RQS. And hey, we said SQ twice, so they share that side. So cool. So we can show these two triangles are congruent by SSS. So we've got so 2 points determine one line, but we know SQ is congruent to itself by identity. And then, as we said, we've got a pair of sides, another pair of sides, and then this is in both triangles. If we broke it out, one here, so we got by side, 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 a pair of sides, another pair of sides, and a third pair of sides. So triangle TSQ is congruent to triangle RQS by the side-side-side theorem. But then remember, when triangles are congruent, corresponding parts are congruent. Okay. So we know that this will equal that. Because remember, in the two triangles, in the second one here, our center letter is Q. And in the top one, our center letter is S. So S and Q are congruent to each other. We'll call it 1 and 2. And then this one and this one, 3 and 4. Okay? So we know that angle 1 is congruent to angle 2, angle 3 congruent to angle 4, by CPCTC, and then since 1 and 2 are congruent, that is 2 is right here and 1 is right here, and if we look at those three lines, it makes a Z. And we're talking about these angles here. So we have alternate interior angles. Those are congruent. And therefore, these lines are parallel. And over here, with 3 and 4, 4 is here, 3 is here. They have that in common. So if we look at that, we're making a Z with that angle and that, so that these are parallel. So we know that TS is parallel to QR and TQ to SR. Because when alternate interior angles are congruent, lines are parallel. And then by definition, QRST QRST is a parallelogram. Definition, parallelogram. All right, good. So now on to the next one. Theorem 5.5. Now, Theorem 5.5 says that if one pair of sides, notice AB and BC is a pair. So one pair of sides, not both pairs, not this pair and this pair, but if one pair of sides is parallel and congruent, then it's a parallelogram. So let's think about what we're going to do. Probably we got to make a triangle again, because what? That's what we've been doing every other time. So if we have a line right here, an auxiliary, a diagonal. Oh, hey, notice we got two triangles here. So ABD and CDB, but then they have this in common. And we don't know about this, so we're probably not going to use side, side, side. Maybe ASA or side angle side. But we have two sides, so probably that. Maybe we'll use these. Maybe we're wrong, but let's see. But so can we get an angle that's congruent? Well, these are parallel, and that's a transversal, so we should. If we have that, that, and that, this is congruent to that, and this would be right there, and this would be right there. So it's this angle. So heck yeah, we got side angle side. So we're able to show that two triangles are congruent. let's do that and then think about the rest from there. So, first of all, we're given AD congruent to BC and AD parallel BC. That's given. And then we know that BD is congruent to itself. It's identity. And then we've seen that, I'll call them 1 and 2. Okay, when lines are parallel, alternate interior angles are congruent. And then triangle ABD is congruent to triangle CDB. Side angle side theorem. But as a result, we know corresponding angles are congruent in opposite sides. Remember, the theorem we just proved says that if you have a quadrilateral and opposite sides are congruent, then it's a parallelogram. But because this triangle and this triangle are the same, we know that's congruent to that by CBCTC. A, B, congruent to CD. And therefore, by theorem 5.4, ABCD is a parallelogram. Done with another one. All right, on to the next two.